Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will have another learning in tNavigator, and today's topic is about arithmetic. All right, I think it's quite simple, but relatively speaking, it is a bit more complicated than the previous cases. Okay, so in this video, we will use arithmetic operation to create properties. In particular, we will create permeability. Okay, so yeah, usually or basically in most cases we use for permeability, we use grid. Okay, so we have specific grid that contains permeability distribution. Okay, and maybe we create that in model designer and then we transferred it to the simulation file. Okay, and yeah, if we go to, for example, files here and then grid, we will have grid, special grid for permeability. But in this case, we don't have such grid, and instead we will create the permeability without grid. Actually, we do not have grid for permeability, but we will use another grid, and that use that another grid to form our permeability. Okay, and that grid is the array grid. All right, so it's about arithmetic operation. So yeah, I will just introduce the case to you. So I'm going to go to file, or instead maybe I can show you the master data. Okay, so this is the case. As usual, of course, we have run spec and title, and this is the description. So actually we have four saturation number region, or we have four regions based on the saturation number, zone 1, 2, 3, and 4. And basically they are this, they are these layers. Okay, and then I'm going to take that again. Yeah. So zone 1, zone 2, zone 3, and zone 4. Okay, to make it more clear, I'm going to go to regions here. So for PVT, we have only one PVT region, rock compaction also. Equilibration, we have four regions. Grid blocks, we only have one. Fibnum one. Saturation and equilibration, we have four. Okay, so one, and then the two, second layer is the purple one, and then the brown, and lastly the light blue. So we have four regions for our saturation, or the zonation based on saturation or equilibration. Okay, and yeah, this is the unit metric, and this is the dimension, number of layers in X, Y, and Z. And then here we have four zones. And then, yeah, we have oil, water. This is the setting for the table for wells, tap dims, rack dims, and scale. This is the start date. And in grid, we have only two grid. The first one is grid.include, and this is important, airsat.include. Actually, we will create this include file. Okay, so we do not rely on model designer to create the grid, but we will instead create this array grid. Okay, so airsat is actually is ARR is array, and sat is actually saturation. So I'm going to take information from saturation region, the four layers, and I will use that for my array. And then for the arithmetic operation, in arithmetic operation, I will produce my perm x, perm y, and perm z. Okay, I will use my perm x, perm y, and perm z. And you see, I will use airsat. Okay, so let's say for AirSat, I will use this formula to get my permeability in X direction, and then AirSat2, AirSat3, AirSat4, and then edit. And then I also have other arithmetic operations, but I don't think I will explain about this in this particular video. So I will skip it and keep it for other videos in the future, hopefully. And then regions and then arithmetics. It is also for another video and others. So I'm just going to focus on this section actually, okay, because this is actually a thing for itself. Okay, yeah, this can stand alone as a learning. Okay, so you see, two most important things in this video is actually we will create this grid AirSat and then use this AirSat to generate our permeability grid. Okay, so that's our game plan. So it will be, yeah, relatively easy actually. All right. Okay, so you see here, we need AirSat for the permeability, and in AirSat, we have 1, 2, 3, and 4. Okay, and again, I call this AirSat because actually I take information from the saturation, okay, for which I have a special grid. Okay, so I'm going to move it first. And then for the saturation, we can find that in files. Of course, we have the grid here. So regions include satnam. So here you go. So this is our grid for the saturation region. Okay, you see, we have this, and then sometimes we have one, sometimes we should have two, and sometimes we have three, sometimes we have four, which means that we have four saturation regions. Okay, and then, yeah, if you want to check others, we have props actually. Okay, let's check, but it's not the main thing here. So we have density, PVTW, and others. Okay, and then this is for rock compressibility. Okay, nothing really special for this particular video. Okay, and then in schedule, not really relevant. So basically we use the saturation. Okay, so I'm going to take this file. Of course, I will go to my folder, and then I will, I will copy this file. I will just copy this file, and then on the keyword, I will change the keyword setnum, and I will use the keyword airsat. Okay, and the rest will be exactly the same. So what do I mean by that? I mean it's like this. What I mean is like this. So I will create a new grid, okay, an array grid, and the information that is contained within the array grid is exactly the same with the information that is included in saturation number grid, which basically region 1, 2, 3, and 4. Okay, so I will create a new grid, and because I will take information from satnum grid, I will call it airsat, and actually the keyword is also airsat, and using the airsat grid, I will distribute my permeability. Okay, so that's why I close this one. That's why here we have files, and then I'm going to grid this one. The keyword is airsat. It's an array grid, but I take the information from saturation number. So if I go to my saturation or regions, all right, this is the satnum grid, and if I show you the airsat grid, they're exactly the same. They're exactly the same. Okay, so I'm just copy everything here, and then or copy the file. Okay, copy the file and then make a new file and just rename the code here, the keyword here with airset, and just rename the file with airset. Okay, so that's it. All right, that's actually it. And then after you have the file, or maybe I'm going to show you the folder first. Okay, so this is the folder. So what I mean is like this, I can just copy here and then Control V and then just rename the file, for example, air thing like this. Okay, actually it's airset. So I open this and then just rename or change the keyword from setnum to airset. Okay, so that's very simple, right? So yeah, I'm going to delete this one and then let's go back to, the user interface. Okay, so after we have the airset grid, let's go back to the master data. Yeah, so let's be careful a little bit. So actually everything will be simple. Run spec, title, metric, here everything. No particular keyword, but let's be slower here. Grid, okay, so let's open the grid. And then include. Of course, we will include the grid. Grid include. And then airset. Okay, airset dot include. Okay, so we generate the airset grid, and then of course we need to input that in the grid section. And then let's use the keyword arithmetic. And then for permeability in x direction, of course the keyword is perm x. And then use this one. If airset double equal 1, which means the airset is 1 here. Okay, or maybe we can go to the airset here. So the airset will be like this. So 1 blue and then 2 is this, I think it's teal color, TEAL, and then the third one is green, and lastly red. Okay, so we have airset double equal 1, then permeability in x direction can be calculated using this formula. For example, we have this correlation 12 multiplied by the exponential of 5 multiplied by the porosity. So basically we need to have grid porosity in this case. Okay, so this case assumes we already have another grid that contains the porosity distribution. Okay, and then else if not 1, what about region 2? And if it is 2, then use this formula. If not 1 and 2, maybe 3, airset double equal 3, then use this formula for the third region. And if not, it means it is the fourth region, and so we use else this formula. Okay, so if blah blah blah, then use the law or the rule, and then don't forget to use this. Be careful, it's different from this slash. It's reversed. Okay, and then else if, then, and then use this slash again. Else if, then use this reverse again. Else if, then use this reverse again. And close with and if. And don't forget, we have another, this usual slash that we normally use here to close the arithmetic operation. And after that, yeah, we can copy the permeability in x direction to be exactly the same with permeability in y direction, like the one we do normally, usually, and permeability in z direction, we can use this formula, this arithmetic formula, perm x multiplied by 10%, for example, and then close with this one. And that will conclude our learning today. So the main thing is that we create array grid, using the available information. And in this case, the available information that I need, that I use to create my array grid is the saturation number grid. And then use arithmetic, okay, operation to generate my perm X. And to generate the perm X, because perm X should be three-dimensional, I use AirSet because AirSet also three-dimensional. Okay, I use AirSet grid and then use this correlation. This correlation is from another source, maybe from your petrophysicist, from your friend geologist, and then use this like this one. So maybe you ask about the poro. Okay, let's find it where the poros. See, I think it's in grid. So let's open include grid. Okay, it takes a while. Yeah. And then, yeah, we have Newton, coordinate, no eco, egnum, and yeah, we must have porosity, but in this particular case, I'm not sure where it is. Oh, here. So we have actually the grid for the porosity, and we use array set grid, and then we have porosity grid to calculate or to generate our permeability grid in X direction, Y direction, and Z direction. Right? So I think that's all. So everything after this is normal, except if you want to extend the learning to include this other arithmetic operations, but I think it's a topic for another day. Okay, so I think we can close. Thank you so much for watching. I hope you enjoyed this video. I hope this video is useful. Thank you so much for watching and see you again in the next tNavigator Eng-Man videos. Thank you.